Welcome to this module on propositional logic and logical connectives. In this module, we'll explore how logical reasoning forms the foundation of data-driven decision-making. We'll look at 5 main logical connectives and see how they are used in real-world data science applications. A proposition is a simple statement that can only be true or false. In data science, we rely on such statements all the time. Whether it's checking if data is missing, if an algorithm converges, or if a query returns results. Propositional logic is about manipulating these true or false statements systematically. To work with propositions, we use logical connectives. These operators allow us to combine, negate, or compare statements. In this module, we'll cover the 5 most important ones: negation, conjunction, disjunction, implication, and equivalence. Understanding these connectives is essential for building queries, constructing rules, and reasoning about models. Negation simply flips a statement. If something is true, its negation is false, and vice versa. For example, if the statement says the model accuracy is above 90%, the negation would say the accuracy is not above 90%. This is often used in data queries to exclude certain conditions. Conjunction means and. A conjunction is true only when both propositions are true. For example, data must be both complete and consistent before we can proceed with model training. This is a common requirement in data quality checks. Disjunction means or. A disjunction is true if at least one of the statements is true. For example, if the dataset is in CSV format or in JSON format, the condition is satisfied. This is especially useful in filtering queries, where multiple formats or options are acceptable. Implication is an if-then statement. It says if P is true, then Q must also be true. The only case where implication fails is when P is true, but Q is false. For example, if we say that if data is normalized then the model will converge, and the data is indeed normalized but the model fails to converge, then the implication is false. Equivalence means both statements are either true together or false together. It expresses an if and only if relationship. For example, the dataset is empty if, and only if, the row count is 0. This is a powerful way of expressing exact logical equivalence. To summarize, logical connectives are the building blocks of reasoning in data science. They help us design filters, build feature rules, and encode decision-making logic into algorithms. A SQL query that selects customers over 18, with income above $50,000, is just one real-world example of conjunction in action.